All right, today we are going to do day 2 of Taylor Polynomials. I understand several of you were not here yesterday. We're going to do a very quick recap, and I'll let you guys help me out since my voice is kind of iffy. Who can tell me what a Taylor polynomial is used for? Do you remember?
It like estimates the point on a curve that's not.
You are on the right track, okay? We learned something last semester called linearization, and we used a linearization to find a point on a curve that was a difficult curve. We used it as an estimate, but it only works nearby. A Taylor polynomial is a higher degree polynomial that estimates values on a curve for us. For example, your calculator, if you typed into your calculator e to the third, it actually does not know what e to the third is. It creates a Taylor polynomial that fits near 3 so well that it and e have the same curvature, and it estimates it from that curve instead. And it takes it out so many places that the answer is exact, because we're dealing with series that converge. That's why we learned series before this unit, because it's going to all tie together as far as series go. What we're doing today is we are focusing on where these kinds of questions show up on the AP exam, okay? But first we need to do a problem to kind of review the procedure for finding a Taylor. Okay, who remembers from yesterday the difference between a Taylor and a Maclaurin? Go for it.
Maclaurin doesn't have a C.
Doesn't have a C. Who remembers what that C is for? Kenya? You don't? Okay. Emma, do you know? What is the C? What is the C?
It's the point that the polynomial is centered around.
Right. It's called a centering point, but it's basically the point where the curve in question, the function, and the polynomial touch each other. It's the point of tangency. Okay? So, with a Maclaurin, C is 0. It's touching at 0. It's a special case of the Taylor. So, this box right here is very important. It was on the notes yesterday, and we're going to bring it up again today. The polynomial is written Pn of x. The n represents how many terms or how many degrees you go out on your polynomial. AP usually requires 4 or 5. And at x equals c is where, like I said, the polynomial touches the curve of f of x. And it creates this long function right here. We need to modify this a little bit. This looks a little different than the one we did yesterday. Please, underneath the f of c, put 0 factorial. Under the f prime of c, put 1 factorial. These have factorial values for each term. Now, we briefly talked about factorial in the notes yesterday, but let's talk about it again. What is 0 factorial? What number does it equal? 1. It's 1. And 1 factorial is also 1. Okay? So down here on this Maclaurin, put a 0 factorial under the first one, put a 1 factorial under the second one. What makes these work so well is the patterns that you see. The derivative number, that's a double prime, the factorial number, and the power of x are always the same. The derivative number, the factorial number, and the power of x are always the same. All right, so what we're going to do on this first example, just to review the procedure, we're going to find the Maclaurin polynomial of degree 5 for sine. So what we do, when it says degree 5, we're going to go all the way out to the 5th derivative of sine. So on your paper, write f of x, f prime of x. You don't have to space them too far apart. Double prime, triple prime. And yesterday on the notes we talked about once you hit triple prime, it starts being written with a parentheses and a 4. The parentheses denote derivative. If it just had a plain 4, it would be a 4th power. So we're going all the way out to the 5th derivative. Because it says Maclaurin, we are plugging in 0, but we're going to do that in a minute. So what we do, f of x is sine. So under the f of x, please write sine of x. The functions that they give you will be ones that are easy to take the derivative of over and over again. What is the derivative of sine? Y'all speak up a little bit. What's the derivative of that?
Negative sine.
Derivative of that? Good. Next one? Now we're repeating ourselves. And then the last one is cosine. Okay? Now we're going to plug in 0 to each of these and see what we get. Now, yesterday in the notes I changed colors. We're going to do it again. What is the sine of 0? 0. Cosine of 0 is?
1.
Negative sine of 0 is?
0.
Then negative 1, 0, and 1. Okay? These are these numerators up here. What I just found are those numerators. F of 0, F prime of 0, F double prime of 0, F triple prime of 0, and so on. Their denominators are the factorials. So we're going to come down here, and underneath each of these, we're going to put 0 factorial, 1 factorial, 2 factorial, 3 factorial, and so on. Now, to write our polynomial, we write P5 of x. Why the 5? Because I went out to the 5th derivative. What does 0 over 0 factorial reduce to? 0. Plus 1 over 1 factorial is 1. Now, this being 0 factorial also tells me how many x's it gets. And since it's 0, I didn't put an x on the 0. However, this is a 1 factorial. That means it gets x to the first. Now the next one, what does it reduce to? 0 over 2 factorial?
0.
That's 0. So I'm going to mark it out. I'm not even going to write it down. And then the next one will be negative 1 over 3 factorial. We leave the factorials alone when they don't reduce with anything. We just leave them as a factorial. What's the power of x for this term?
3.
3, because it was 3 factorial. The next term is 0 on top, so it's going to go away as well. And then we write plus 1 over 5 factorial, and its x's power is 5. All right, so this right here is what is called the 5th degree Maclaurin polynomial for sine. So that means, and I'm not going to take the time to do it, if I graph sine and I graph this on the same graph, they will be almost identical. I mean, like over a long period of space at 0, because 0 is where they touch each other. Okay? Actually, let's take the time and go ahead and graph that. Take your calculator. That's an easy one to put in. You can't see this, so we're going to have to adjust. I'm going to turn the light on, the lamp on, because it makes it worse for the iPad, but it helps with the calculator. So let's just type sine of x in here. Now the polynomial goes in second. You don't need to type in the 0, so we just type in 1x minus, I'm going to put in the fraction bar, 1 over, now, factorial. What is 3 factorial?
6.
It's 6. 3 times 2 times 1 is 6. X to the third. And then plus 1, oops, that's okay. If you put the numerator in first and then do the fraction bar, it knows to put that number on top. Now, just for the benefit of those who weren't here yesterday, the factorial key, if you don't know what 5 factorial is, you can type in 5, and then the math key, and then the PRB, and number 4 is the factorial. It's usually quicker to go ahead and multiply it out, 5 times 4 times 3 times 2 times 1. You could have put that on the bottom if you wanted to. Okay? Now, if we do a zoom 4, here comes sine, And here comes the Taylors. And do you see that around 0, they're the same graph. They're exactly the same graph. And it's much easier to find something like the sine of 0.2 plugging it into the polynomial than it is to plug it into sine. This was very beneficial back in the day before they had calculators to do math. This is how they estimated sine values that were not 30 and 45 and things like that. Okay? So notice that they are almost exactly the same graph around 0. That's where we're talking about. Okay? Now that we have them in here, we're going to need that for part B. Find P5 of 1.4. What does that mean I'm supposed to do? Plug in 1.4 to the graph. Now, on the calculator yesterday, those of you who were here already made this change. I want everybody to go ahead and push second and window. And if your calculator does not say ask for the independent, please change it. And now we're going to go to the table, second and graph. They want to know what it is at 1.4, so we type in 1.4. Which column gives me the polynomial answer for 1.4? The second one. So I'm going to come up to the second one and highlight it so I can see all the decimals. Because the answers are so close, I want to go ahead and write out all the decimals. Actually, about 6 decimal places. 0.987485, repeating. That's good enough. Now the next question said, what is f of 1.4? So what is that value? How do I find it? It's the first column. It's what's in the first column. So that is 0.985450. Let's go 50. That's good enough. Now, the next 2 lines go together. It says, what is the error of your approximation? In other words, how far off is the polynomial from the real answer? So, what I'm going to do is go back to the home screen, and I'm going to teach you a little trick. Okay, I don't think I've done this before. It says it's the absolute value of f of 1.4 minus p5 of 1.4. Absolute value just makes it positive, okay? So what we're going to do is we're going to type in y1 on this screen. Remember how to do y1? What do you push? Alpha trace and enter. Then put a parentheses 1.4. That's telling the calculator I want to know the y value for the first equation at 1.4. So it's going to pull that decimal and all of its decimal places over. Now minus, I want the other one. So I'm going to do alpha trace y2 parentheses 1.4. I'm not going to worry about the absolute values because I can make it positive myself. I don't have to go looking for that button. And what do I get? The error is negative 0.002035. So those 2 estimates are pretty close. But I don't want a negative, right? So let's fix that. And I'm going to write underneath here what I typed in so I know next time. y1 of 1.4 minus y2 of 1.4. That's what I typed in the calculator. I would like you to answer the questions for C, please. Right now on your paper, answer the questions for C. Are these the answers that you're getting? Does that look pretty good? Okay. Now, how does the error for the one we just did compare to the error from the previous one?
The second one is more off.
The second one is much more off. The second error is larger than the first. Why?
Because it's further removed from the center point.
It is further away from the point where the 2 curves touch. Anytime you move out, your error between the 2 graphs is going to get bigger. What do you think would happen if we use this curve to estimate the sine of 2.7? How would the error look? Would it be bigger or smaller than the other two? It'd be a bigger error. The error would be even bigger because 2.7 is farthest from 0 of I wrote faux, of all 3 points. The error would be even bigger because 2.7 is farthest from 0 of all the 3 points that we've done. So the closer you are to the point of tangency, the better. Farther away, gets off some. When calculators build Taylor polynomials to find values, they can go out not 5, they can go out 15 or 20 and do the math in an instant. That's why their estimates are so much better. Okay? Any questions on what we've done? All right, turn to the next page, please. All right, for the next example, it says given P2 of x equals a plus bx plus cx squared is the second degree Taylor polynomial for f about 0. So basically what it's saying is here's f, and there's a second degree Taylor polynomial that hugs alongside of that one, okay? What are the signs of a, b, and c if f has a graph pictured at the right? And we can find that information out from this equation, okay? So we know that both the graphs touch at 0, okay? So we're going to take, first of all, we're going to find the sine of a, the sine of b, as I wrote a again, and the sine of c, and we're going to write them over here, and y. And I'm going to do some work over here. So P2 of x equals a plus bx plus cx squared. I know that looks backwards, but that's the way that Taylors are built. They start with no x, then 1x, then 2x's, and so on, okay? If I plug in 0, what am I going to get? If I plug in 0 for x, I'm going to get a plus 0, which is just a. So this point is the same value as a. What sign is that point up there? What sign is this point right there? Positive or negative? Positive. Positive. Why? Because a is it's what? A is positive. A is positive because I am where? Above the x-axis. A is positive because it is the y-intercept. It is where the graph crosses the x-axis. Okay? Now, let's take a look at the derivative of this thing. P prime 2 of x equals, what's the derivative of just an a if it's a constant? 0. What's the derivative of bx? B. And what's the derivative of cx squared? 2cx, right? Because the c is a constant. Now, if I plug in 0, what am I going to get? 0 plus b plus what? 0. Agreed? So the first derivative is the value of b. Now, on a graph, what does the first derivative tell us? Whether the graph is blank or blank. What are the blanks? Increasing or decreasing. What is this graph doing? Increasing. So what sign is b? It's positive because f is increasing. That's how I know. All right, let's take the double derivative. Go back to here. 0's gone. The derivative of b is what if it's a constant? Not 1. 0, because it's a constant, right? Derivative of any constant, 0. What's the derivative of 2cx? 2c. Right? Yes, ma'am.
I thought the derivative of constant was 1.
No, the derivative of just an x is 1. Okay? So, 2c. What does double derivative tell us about a graph? It tells us concavity. What kind of concavity does this graph have? It's concave down. So what value, what sign does c have to be? Negative. Because f is concave down. Y'all see how that worked? Yes, ma'am.
So if you were to do this like on the exam, would we get like knocked off if we don't put like the 2 under the can we just...
If you can look at it and just tell me A, B, and C based on where they are, you don't have to show all this work over there. Okay? Yes, ma'am.
So for A and B, well, we get A and B from looking at a combination of the graph and the math we did, right?
Yes.
Okay,
Yes.
got it.
We said that when you plug in 0 for x, the y value is a. So a is the y value of my curve. The y value is positive. The derivative was b. b is the slope of my curve, because derivative means slope. Is the slope of that curve positive or negative? Positive. That's why we got a positive. Does that help?
Yes.
Okay. Yes, ma'am.
And since the back is going this way, is that why it's concave down?
It's, yes, because it's curving downwards. Concave down is like a frown. Remember that? Okay. Any other questions? All right, go to the next question, which ties to this one. Oh, no, it doesn't. It's a different one. Suppose that the function f is approximated near 4. So in other words, the Taylor is centered at 4 by the third degree. They've already built the Taylors for us. The question says find the value of f of 4, f prime of 4, f double prime of 4, and f triple prime of 4. Okay? So what we're going to do first, take your flip book to help you. I know what the formula is. You can look at your flip book. And since this is centered at 4, it's a Taylor's. We're going to write it out with the formula. So what I want you to do is write the formula, putting the number 4 in for all the c's. So we're going to put P3 of x equals f of 4 over 0 factorial. Isn't that the first term? F of c. And there's no x on it. Then f prime of 4 over 1 factorial, x minus 4 to the first. Remember that the derivative number, the factorial number, and the power on x are all the same number. Plus f double prime of 4 over 2 factorial, x minus 4 squared, plus, you tell me, what goes on top? F triple prime of what? What goes in the parentheses? 4. What goes on the bottom? 3 factorial, and then x minus 4 to the third power. It's taking the formula on that red piece of paper you pasted in, changing all the c's to 4's. All right. Now what we're going to do is match up our formula with the Taylor polynomial that they gave us. So I'm going to use my highlighter to help me. F of 4 is the first thing they want. Now notice where f of 4 is. It's over a 0 factorial, and it does not have an x on it. Which term in the polynomial they gave us has no x on it? The 2. And since 0 factorial is 1, that means that f of 4 is 2, because they're in the same location. So we're going to write f of 4 is 2. We're done with that. All right, I'm going to change colors here. Now f prime of 4 is the top of the next fraction. And it's on top of the fraction with the x minus 1 to the first power. What is the number in front of the x minus 1 to the first power? It's 0, because there isn't one. Does that make sense? So that tells me that f prime of 4 is 0. There is no x minus 4 to the first term. I'm writing that down as a reminder, so when you look at this later, you know how I got 0. All right, the next one, let's go with green. F double prime of 4 is next to the x minus 4 squared. But notice that it doesn't have a denominator. The number in front of the x minus 4 squared is -5. So we're going to take this fraction and set it equal to that number and solve it. So I'm going to come over here and say, let's change colors. We're going to say f double prime of 4 over 2 factorial equals -5, because that number and that number are in the same location. Do y'all see what I mean by the same location? They both have the x minus 4 squared on the end of them.
But what is the -5? Oh, wait, just that one, right?
Yes.
I thought you saw something about it.
No, that's where it came from. Now how do I solve for f double prime of 4? Just multiply both sides by 2 factorial. So f double prime of 4 equals what number? -10. So f double prime of 4 equals -10. Did you follow the math I just did? Okay, do you think you could do the triple prime? Try the triple prime yourself.
Oh my God. Yes.
So, as I walked around, it looks like most everybody got 48, and that is the correct answer. All right.
I'm just
So, let's talk about the next question.
Let's go.
Yes.
Can you explain like real quick?
All right, got that?
Yes, please.
Okay. So, not that. I want this. So, the f triple prime is right here. It's in front of x minus 4 to the third. So I go over here and say, what's in front of x minus 4 to the third? Oh, it's 8. So I'm going to set up a problem that says this fraction equals that number. F triple prime of 4 over 3 factorial equals 8. Multiply both sides by 3 factorial. Three factorial is 3 times 2 times 1, which is 6. And that's where 48 came from.
Thank you.
Good. Okay. Next problem. Does f have a local max, a local min, or neither at 4? So, back to maxes and mins, way back when. What has to be true in order for something to have a max or a min? Where do you start the process of finding maxes and mins? You set the what equal to what? The derivative equal to 0. Now take a look up here where I'm pointing. Does the derivative at 4 equal 0? Yes. So there is a possibility that it is a max or min. Okay? Now, we learned 2 different ways to find out whether something was a max or min. What was one of the ways we learned? The number line. And that's the most common. We would put f prime there, we put the 4 on it, and then we would test points on either side. Okay? Do we know anything about what's happening at 3 and what's happening at 5? No. So this is not the method I want to use. Okay? I know that f prime of 4 equals 0. What's the other way? The second derivative test, where you take a look at what happens at the second derivative. What did it tell me about the second derivative? I just found it. It's -10. And the fact that it is negative means my graph is what? Concave down. So f is concave down. And you've got to specify that it's f. So if you want to draw a picture to help you, draw a picture of concave down. So at 4, does it have a max or min or neither? It has a max. Therefore, there is a local maximum at x equals 4. And I have just justified my answer because I used the second derivative knowledge to find out what that max or min was. Okay?
What if you just state there's like a local max because prime is 0 and a double prime is negative. Is that okay?
That is fine, yes. Kevin, question?
No, it's okay.
Okay. All right. Next problem. The function f has derivatives of all orders. Now what that means is that you can take the first derivative, second derivative, third derivative, fourth derivative, and so on and so on and so on. That's what it means. And for all real numbers x, assume these answers. They already found them for you. It's kind of like the same problem we just did, but backwards. Now, I want you to build the Taylor polynomial around 3. Okay. I'll get you started. So what do we write? P what? P3 of x equals. Look at your flip chart if you need to. What does the first thing say if it's a Taylor polynomial? F of c over 0 factorial, which is just 1. So we're going to write f of 3. If you want to put over 0 factorial, you can. You don't have to. Plus, what's next? F prime of 3 over 1 factorial. And then what?
X minus 3.
X minus 3 to the first. You don't have to put the first, but I do it to show that the 1 factorial and the 1 power are supposed to be the same. Now you write the next two terms in, plug in the numbers they told you all those primes and double primes were, and clean it up. Okay?
Okay.
I'll give you a second to do that.
When it asks for the third degree, that means to go out to...
No, you go out till you have taken the third derivative.
The third derivative.
Yes.
It says third degree.
Yes, third derivative means third degree, because you'll end up with an x to the third power.
Okay.
Yes. Okay, when you're done, look at the screen and see if you got what I got. After you clean it up. All right. The question was just asked, and I'm saying it for the recording, could I go straight to this line if I was doing it on an AP test? And the answer is yes. If you could do that in your head, you can go straight to the answer. Okay? Now, part B is tough. I'm telling you right now. I'm going to simplify it a little bit just to help you out. We're going to do this as a third degree Taylor polynomial, because it gets rather tedious after that point. Okay? So what I want you to do is to do the first line. Now, in this case, we need to write the first line. It's very important that we do. So we're going to do a P3 of x equals, they want a Taylor polynomial for g, which equals this, at 0, not at 3. So what's the other name for a Taylor polynomial at 0? A Maclaurin. So they could have called it a Maclaurin, but they decided to call it a Taylor at 0, same thing. Okay? So the first term is going to be g of 0, 0 factorial. Then g prime of 0, 1 factorial. Now you don't have to write x minus 0, just put x. Plus g double prime of 0, 2 factorial, x squared. Plus g triple prime of 0, 3 factorial, x to the third. Maclaurins are so much easier to write because you don't have to worry about all those extra numbers. Does everybody understand where that came from? Okay, eventually you'll get to the point, you have to by the AP test, to generate that yourself without looking at the formula. But it'll come. The more you practice, it'll come. Okay, now we need to find all those numerators. They didn't give them to us this time. So, g of 0 I am given g of 0, I'm given g. So I can just plug a 0 in for this x and a 0 in for that x. So what is the right side going to say? F of 3. So f of 3. Do I know what f of 3 is? It's negative 4. So the first term's done. Now g prime, I don't know what g prime is yet, so I have to do g prime of x first. Then I can plug in the 0. So I need to take the derivative of this function over there. I need a rule. What rule do I need to take that derivative? I need chain rule because it has an inner function. Okay? Remember how chain rule goes. Derivative of the outer and then the derivative of the inner. How do you write the derivative of an f? F prime. So we just write f prime of x squared plus 3 times 2x. Okay, so there's the first derivative. Now they want us to find g prime of 0 according to the formula. So I'm going to plug a 0 in. G prime of 0 equals f prime of 3 times what? 2 times 0 is 0. So I don't even have to go look and see what f prime of 3 is. What's my answer going to be? 0. So that means there will be no g prime term at all because the numerator is 0. Does that make sense to you? If I put a 0 on top of that fraction, there's no fraction. Are we good? Okay. I'm going to leave some space at the bottom for my answer. Okay? I'm going to leave that open for my polynomial when I'm finished. So I'm going to come over here and do the g double prime. All right. I need to take the derivative of that. See what I highlighted? I'm going to need chain rule for that f prime part, but what else am I going to need? 1d2, the product rule, exactly. So let's carefully do the product rule to this one. So 1, oops, I'm writing in highlighter. 1 is just copy f prime of x squared plus 3 times d2. What is the derivative of 2x? Just 2. 1d2, done. Plus 2, which is 2x, times d1. Now I know I'm trying to shrink down so you can see better. What's the derivative of this f prime part right here? F double prime. Good. F double prime x squared plus 3 times 2x. Don't forget that inner derivative. Okay? So there's my 1 d2 plus 2 d1. The d1 needed chain rule.
Can you not make that again, please?
Yeah. This is 1, this is d2, this is 2, and all of that is d1. So 1, just copy the f prime down. d2, the derivative of 2x is just 2. And then copy the 2. And now take the derivative of this. The derivative of an f prime is an f double prime. So it's f double prime of that, but it's got an inner function, so you got to take the derivative of that inner part too. And that's that extra 2x on the end. Okay? Now, we need to plug in 0. Now, what's going to happen here? That's going to be f prime of 3 times 2, right? I'm going to erase these 1d2s just to kind of make it a little easier to see. There we go. Plus, what's going to happen down here when I plug in 0? It's going to be 0, isn't it? So I'm not even going to mess with that because I know because of that x on the outside it's going to be 0. So f prime of 3 is 2 times 2 is 4. And there's my new numerator for double prime. All right. Now, time for triple prime. So, I told you this was intense, huh? This is long. Okay. Whoops, wrong page. Go back. Here we go. I need to clean this up. See where I'm circling? I need to clean this up a little bit before I do the triple prime. So, this 2x times this 2x is what? 4x squared. And I'm going to put that in the front, because I'm going to have to take the derivative of that. Otherwise, I have to do like a 1d, 2d, 3, and I don't want to go there. Okay, g triple prime of x. And every time you do this, you've got to take the derivative first, then plug in the 0. So look at, let's change colors. Look at this. Do I have to do 1d2 with this again? No, I really don't, because 2 is a constant. Constants just sit there. So the 2 goes in the front. What's the derivative of f prime of the parentheses? F double prime of the parentheses. Is that all? Every time we take the derivative of that, what do we have to put on the end? 2x. The derivative of the inner, because it's chain rule. Okay, that takes care of the yellow highlighted part. Okay, now I'm going to highlight the next part in green to help it stand out. Here we go. 1 is 4x squared. D2 is going to be f triple prime of x squared plus 3 times that 2x again, plus 2, which is the double prime, times the derivative of 4x squared. What's the derivative of 4x squared? 8x. Okay. Now those of you who could do a lot of math in your head are seeing where this is going. If I plug in 0 for all the x's, let's do it a little bit at a time. G triple prime of 0. What about here? If I put a 0 right there, what's going to happen? Bye-bye. If I put a 0 in here, in the second term, what's going to happen? 0. If I put a 0 in the third term, right there, what's going to happen? 0. The triple prime is 0. All that work for a 0. That's frustrating, but that's college math. Everything canceled out. Okay? Now, the problem wanted you to go a 4th time. I'm not going to make you do it. Okay? Thank you. I did it in first period, but I'm not going to do it with y'all. So P3 of x equals. Now we just take our answers, and we box this one in. Put your answers on top of your fractions and clean them up. Yes?
Extending that further, would all odd terms be like 0?
I believe so. Yes. And it would form that kind of a pattern. Okay, so the first term, -4 over 0 factorial is just -4. Now remember, the next term goes away. Oh, and so does this one. So we can mark that out because we just found triple prime is 0. Plus, double prime, what did we get? 4 over 2 factorial x squared. Now that looks kind of weird because usually this number on the P matches our highest power, but in this case the highest power had a constant of 0. Okay? So there is another term on the end. Now if you want to have a challenge and write it, I'll tell you right now that the next term is going to be 84 over 4 factorial x to the 4th. If you want to go home and try it. If you want to go all the way out to the 4th. Now, this question being so intense would probably give you at least 2 points on the AP test. 1 for finding the correct numbers, and 1 for plugging them into the polynomial correctly. So, even if you mess up somewhere, and you got like the wrong number here, if you put them on your Taylors correctly, you will get points for that, even if your numbers are wrong. You follow what I'm saying? I can't guarantee that, but that's the way after my experience with grading, that's what I think they would do. All right? Questions? All right, that's it for today, and we are done.